Okay, good morning, everyone. Uh, this is our second class about the measurement of central tendency that is related to the statistics, biostatistics. That in the first class we study about the basic definitions in biostatistics, and now today we will just study about the uh, measurement of central tendency and biostatistics. I- Okay. Now, what is like center tendency or measurement of center? So, what is center tendency? Or center tendency we can also call average. Like the center tendency is like the point around which all the data act, or the central point in the data set. For example, if you take an observe or in a measurement from any sample, if you take any measurement from a sample, so the one point, exact point from all your data set is the central point. So the same number of data or number of observation are present on the one side and the same is present on the left side. So this is called central tendency, to the point around which all the data act. So the data set can be summarized into single value, such as the value usually in the center or around which the whole data has tendency to concentrate, or the tendency of an observation to cluster in the center part of the data is called center tendency, and the value is a measure of central tendency is or this is also called average. It indicates the general positions of the distribution of the data sets. It's actually tell us about the information about the general positions and the location of individual data, and it's also give us an information about the data, whether it is if there is any skewness or any outlier in the data or not. Now the properties of good average or the good central tendency, it is, so the first one is it's based on all observations, all the measurement, and the second one is easy to calculate and simple to understand and interpret. It can easily be interpreted. Number third one is relatively stable and repeating the procedure. So if you repeat the procedure from the left side or from the right side, so the main interpretation doesn't change. So this is the main properties of the good tendency. It is not influenced by larger or smaller observations. So the good average is not influenced by smaller value or higher value. Now the types of center tendency or average, there is three main types of the average that we talk that we talk in the biostatistics or statistics. The first one is mean, second one is median, and the third one is mode. Mean, best known and most widely used average describing the center of the frequency distribution. Mean is a very easy term and everyone can understand. Is like when you collect the data and you actually sum up the total number of observation and divide sum up all the data and then divided by the number of observations, so you get the mean. The second one is median. I will discuss each one and the next slides in detail about them. The median is the middle point of the set of the order number below which 50% of distribution fall. For the median, the world order is not important. It's not compulsory that you order the data. You just collect, you just edit all the data. It's not important that you edit them in order. It's not important, but for the median, order is important. For the mode, order is also important. So the middle the we have ordered the data and you find one exact value below which 50% of distribution fall. This is the median. We will discuss in the next slide about this. Mode is the most frequently value or category in a distribution. So when you order them and you found order is not that much necessary in the mode, but it is good to find out the exact or the most repeated value. So the most repeated measurement or repeated observation is termed as mode. Now let's talk about in detail about mean. it is an arithmetic average of the set of numbers. So it is an arithmetic average, mean the value obtained after following the arithmetical procedure like addition and division, the arithmetic principle of mathematics, like sum of the value of all observation and the data set divided by total number of observation. Okay, so mathematically the sample mean is denoted by x bar, and population mean is denoted by mu. Okay, and the x here, summation of x mean is the sum of all data value, and n mean number of data items and samples. Okay, and mu here again the summation of all the data value, and n is the sum number of data item and population. So it is for population, and the big N, capital N mean the item, the number of data set and population, and the N means smaller N mean it is number of data set and sample. For symmetrical distribution, if the data is symmetrical distribution, as we talked in our previous lecture, that there is two type of distribution. One is symmetrical, the second one is skew distribution. So if the data is symmetrical distribution, so locates and the data the mean is locates and the central. Okay, and likely to be affected by extreme values. Mean is that the mean value is actually affected by extreme value. If one side is more value or is bigger values like of the observation, so it's affect the mean. Examples. Now let's talk about the example. That, for example, we have this patients. For example, we have 1, 2, 3, 4, 5, 6 patients, and this is the age of the patient coming to the clinic. So these patients, the one first age 57, 86, 42, 38, 90, and 66. So we have to sum up and then six number of patients. So divide the number of patients by the all the dates, all the ages. So summation of all of them is equal to 379 divided by 6, which is equal to 63.167 years. So as we talked in the previous, it is affected by extreme value. So instead of 57, if we have 67 or 77, so the mean will also change. That's the basic principle of mean. This is the second example is the score on exam. For example, in 100 out of 100 you get 68, 90, 77, and these are the number of marks that you obtain divided by the number of total number of papers. For example, 1, 2, 3, 4, 5, 6. So divide them by 6 is equal to 81. Now I hope you understand the mean. Now let's come toward the median. And the median is the middle value in the order array of number and is unaffected by extremely large or extremely small value. We will talk about this in the next slides, that why it is not affected. Now, application of median. The central position of quantitative data in any distribution could be described by median. Okay, median is mainly used in skew distribution. Skew distribution is if the data is not normally distributed. It's so that is called skew distribution. For example, this is the point, and on the left side it has, for example, more data compared to the right side. So this is called skew distribution, or in vice versa. For example, the right side is more data compared to the left. So it is called the skew distribution. The relationship of mean and median is both measure the central tendency of the data. So if you want to know about what is the relation between mean and median, so you have to, for the normal distribution, mean is equal to mode. But for the positive skew data on left, if the left side is or right side is more data, so in that case, x is mean the mean is greater than median. And for the negative skew distribution, in that case, mean is less than median. These are the points that you have to keep in mind, because this will helpful for your learning. It may come in the any exam or something like that, and it's also good for remembering. Now, procedure for calculating medians. As we discussed about the procedure for how we calculate the mean, now let's talk about the procedure for calculating median. First, as I talked before, that arranging or ordering is important, but doesn't depend on ascending or descending. Just order is important, whether you draw it, order them in ascending order or descending order, but you have to order it. The second point is, if there is an odd number of terms, the median is the middle term of order array. We will discuss this point later. If there is an even number of the term, the median is the average of middle two terms. Okay, keep these 2 points in mind. Median, this is an example of an odd number of terms. For example, these are the odd number of terms. Odd number of terms mean there are 17 items in the order. Okay, these are 17, so it is odd. Position of mean, if it's odd, so then you have two procedure to find the median. One is this formula, n plus 1 divided by 2. N is total number of observation, which is 17. So 17 plus 1 is equal to 18 divided by 2 is equal to 9. So the ninth number is your median. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the median, is the ninth term, mean 15. 15 is the median, not the 9. Mean this is not 9, but the ninth number of observation, because you take number of observations and then divided by 2. So it is the value 9 is your median. If 22 is replaced by 100, for example, this, the median is still 15. But if 3 is replaced by 103 minus 103, the median is still 15, because we don't add all of them, we just count them and then find the point by this formula. Okay, we just count the number of observation irrespective of the quantity of each observation. So that's why it is not affected by what we call the extremely large and extremely small value. This is the example for even number. For even number, first you have to orderly arrange the age of the patient or any data set. You have to order them, and the ascending or descending order, there are 16 items in the order. So 16 plus 1 divided by 2, which is equal to 8.5. So 8.5 number of 1, 2, 3, 4, 5, 6, 7, 8. So 8.5 mean it is somewhere between 14 to 15. For that reason, you have to add 14 plus 15 divided by 2. So when you got this, is the median is the 8 and 9 terms, which is 14.5. If you divide them, it will also give 14.5. So the 21, if this is the median, is somewhere here. Okay, so if we replace the 21 by 100, the median is still 14.5. If 3 is replaced by minus 88, the median is still 14.5. Now coming toward the third term, that is mode. Mode is the observation that occur most frequently. Okay, most frequently. The first one is the mean, is like we sum up and divide by total number. This is the mean. And then for median, you have to order them, and and then the middle one, from which the same number of observation here and same number of observation on the left and right side. So this is the median for the mode. So the number of most frequently figure, most frequently observation is called mode. Mode is always at the peak of frequency distribution. So as we know, it is the most frequently. So when we draw a graph for the mode, so the mode will be always at the peak of the frequency distribution, because the frequency distribution is like the graph increases when the frequency of that figure is increased. So when you draw a graph, the mode will, you will find it at the peak of the frequency graph or frequency table. For example, the 5 salaries, we have 6,000, 10,000, 14, 5,000 and 1,000 and 10,000. Sorry, so the mode is 10,000 because it is 2 times repeated. It is the mode. Now mean median mode for group data. All this data that we talk, it was not group data, it was just the some simple data. But for the group data, so for group data we cannot find exact mean, median and mode. We can only give estimate. To estimate mean, use the midpoint of the class interval. For example, we have the class, we about, for example, the adolescents we categorize it from the age group from 13 to 20, for example. So to find out the mean, we have to estimate the midpoint of 13 and to 20 divided by 2. So this is for the group data. We have to count, we have to sum the larger the small value and the large value and then divided by 2. So this is the way to calculate the mean of the group data. Now the empirical relationship between mean, mode, and median. This is also a important slide. So for the symmetrical distribution, if the data is symmetrically distributed, it is that no outlier and no skewness. So and that type of data, mean will be equal to median and which will be equal to mode. So all of them will be equal. But for the skew or asymmetrical data, this will mean will not, this will, these three terms will not equal. Okay. All the standard tendency, the tendency for mean, mode, and median will be different. Okay, so that's why mostly in research we prefer to get a data or to get a symmetrical data, because for symmetrical data the result is more accurate. For the symmetrical data, empirically it has been observed that moderately, if the data is moderately skewed distributed, not too high skewness, but it's moderately skewed. So for that cases, mean minus mode is equal to 3 time of mean minus median. This is also the main formula you have to keep in mind. Now let's talk about the second, the fourth thing that mostly we use in the statistic for finding about the data distribution, that is called quartiles. Quartiles, as the name denote, that quartile are the value that divide the list of numbers or observation into quarters. So the three values that divide the distribution into four equal parts are called quartiles, denoted by Q1. So Q1 is mean the first or lowest quartile. The values that actually divide the data set, set and get the lowest part of first lowest 25% of the data, it is called Q1. Q2 is actually the data set below the point where 50% or around 50% of the data exist. This is called second quartile. And the third quartile is the value below which 75% of the data exist. So this is the third quartile. So and the quartile, we also use the second term, actually percentile. So the Q1, the value below that is actually they are called 25 percentile. Okay, because the value below Q1 is the value is 25% of observation or the data exist, and Q2 is, we say that 50 percentile, because below that value 50% of the data exist. And for Q3 we also say it is 75 percentile, because below this value 75% of the data exist. The second term is we also use in the quartile is interquartile range, which is also called Q2. Q2 is equal to Q3 minus Q1. Actually, interquartile range give us about the distribution of the data. So if it is more toward Q1, so it's mean it is negative skewness, and if it's more toward Q3, it's positive skewness toward the right and toward the left. So it actually show us the distribution of the data, whether the data is normally distributed or it is positive skew or negative skewness is present in the data. So it is also very most important important thing about the distribution of data. Now, how can we calculate the quartiles? Okay, Q1 or Q2 or Q3. So if these are the data set, so first we have to arrange the data in orders. Again, a range of the except mean and mode, order is important. Arranging the order is important for every other uh, mm, tests. So arrange the data in orders. We arrange the data in order. Step 2 is find the median, which is also called Q2. To find the median, we know from the previous slides that this is the procedure, right? N plus 1 divided by 2. So n plus 1 is how many observations are there? 1 2 3 4 5 6 7 8. So 8 plus 1 is equal to 2, is equal to 9 divided by 2, which is equal to 4.5. Again, 1 2 3 4. So 4.5 is equal to 13 to 15. So we sum up 13 plus 50 divided by 2, it is 14. So it is somewhere between there. So Q2 is here. Now find the median of the data value less than 14. So the less than 14 is 1 2 3 4. Again, it is even. For even, we have to sum up these two. 6 plus 12 divided by 2 is 9. So Q1 is 9. 9 means it is somewhere here. So below which 25% of the data exists. Okay. So for to find out the median of the data greater than 14 or greater than 14 mean it is Q3. Okay. So Q3 is this data, greater than 14 is this data. We find the Q3 here by following the same procedure. So Q3 is 20 and Q1 is 9. Now percentile, this I talked about earlier, that it is actually divide the data into 100 equal parts. 25 percentile and 50 percentile and 75 percentile. So there we also have 1 percentile, for example, denoted by P1. The 99 values divide the data into 100 equal part is called percentile. The average advantages of percentile, it is very simple and clear. We just divide them and 100 equal parts. And but the advantages, it is very rough classification, or just division is very rough because there is might be a chance of error. Only there is some characteristics, only use the two extreme value, do not make full uses of the data. And percentile, we use the 100% or 25%, or like it's not common that we use 1 percentile or 2 percentile. We mostly use 25 percentile, 150 percentile, or 75 percentile. So we mostly use the extreme value, so not full use of the data. Result might be increases when enlarging the sample size, because more chance to include the extreme values, because so it is also affected by extremely large or extremely small values, irrespectively, like the mean and mode. Unstable when data is skew distribution, so it is not good for skew data. Now the fifth term is decile. As the name shows, as when we divide the into 100 groups, and the 100 groups, so the 9 values which divide the distribution into 10 equal part is called decile, denoted by D1, D2, D3, and D9. So this is the main, this is one graph that actually combine the quartile, percentile, and decile. So first quartile, Q1 is equal to P75, mean 25 percentile, and 1 decile is equal to 10 percentile. And a second quartile, Q2 is equal to 50 percentile, and second decile, D2 is equal to P20, means 20 percentile. Similarly, the Q3 is equal to third quartile is 75 percentile, and fifth decile is equal to 50 percentile, because here we divide the data into 10 equal parts and we take the fifth part, and here we divide the data into 100 equal part and we take 50. So the 50 and 5 fifth part out of 10 and 50 part out of 100, they are similar. So here second quartile is equal to fifth decile, 50 percentile, which is also equal to median. Now quartile, decile, percentile obtained by equal subdivision of a given data set are collectively called quantiles or fractiles. Mostly the quantiles and fractiles are used for the large sample size or the large data. Okay, because it is very good for the large data. We use quantiles rather than decile or quartiles or percentiles. So that's why we use quantiles combinedly. Outliers. Outliers are actually the data is an extreme value, extremely large or extremely small. Okay, not outliers if the data is here, all maximum of the data is here, and only one data is present here outside, and one is here. So these are called outliers. Okay, uh, compared to the rest of the data. Now proceed to identify how we identify the outliers. First, we have arranged the data in order to find Q1 and Q3, then find the interquartile range, it is which is Q2, Q3 minus Q1, multiply the interquartile range by 1.5. This is the basic formulas or the basic steps. Like why we use multiply by 1.5, it is just fixed, it is statistics. Subtract the value obtained and step 3 from Q1 and add the value to Q3. From Q1 and add value to Q3. Check the data set for any data value that is smaller than Q1 interquartile range and larger than interquartile range. Okay, now we will do example. From example you will understand it. This is the data, and we actually arrange them in the ascending order. Step 1 is find the Q1 and Q3. So Q1 is from the previous example, you will understand it. So that's why I left here for you, that you have to calculate the Q1 here, which is 9, and Q3, which is 20 here. Find the interquartile range, which is Q3 minus Q1. So 20 minus 9 is equal to 11. So multiply this value by 1.5. So 11 multiplied by 1.5 is equal to 16.5. Subtract the value obtained and step 3, 16.5 from Q1. Okay, Q1 is what? Q1 is 9. If we subtract 9 of okay, we subtract 9 from 16.5, we will obtain minus 7.5, and we will subtract it also from 20 from the Q3, we will get 36.5. So now these are actually the main values. Now let's see which value is beyond 36.5. So 36.5, 36, it is actually 50. So 50 is not in the range of 50, not in the range of 36.5. So actually 50 is outlier. And the other side, f minus 7.5, so there is no value in this range, like beyond this range minus 7.5. So there is no outlier on the left side, but there is outlier on the right side. So it is 50 is the outlier. The more is the outlier, the more skew is the data. Okay, if there is no outlier, it means the data is normally distributed. Reason why outliers occur. Okay, like we say that outlier occurs in the data. So why it's occur? First, the data value may be result from measurement or observational error. For example, if you do measurement from vernier caliper and there is some error in the vernier calipers or microscope gauge, so in one measurement it gave you, for example, 22, but in the next measurement it gave you 32 because of the error, measurement error or observational error. Okay, or you doesn't observe it clearly, you doesn't write it clearly. So because of that type of error, the outlier occurs in the data. Secondly, the data will maybe result from recording error. For you didn't record it properly. Okay, maybe being written or typing incorrectly. For example, you write in the SPSS, you enter the data, and instead of, for example, you 23, you like 33, or 45 you write 55, 40 you write 54. Okay, so these data are this can lead to outlier, and this actually also give you the to think over your data, that if the outlier come in your data, so you have to recheck the data, that whether which type of error occur from me, whether it is a recording error or typing error or observation error. So you have to take the data again. Third, the data value may have been obtained from a subject that is not in a defined population. Okay, uh, they're not in the defined population. For example, you take a data from, for example, you take a test, okay, from 7th class student, but on that day you take a test. For example, there is one student that is actually not in the 7th class, and he is actually from 6th or 5th class, but he came there to like that he has special permission to join this class. Okay, so he might get very low score from this and this test, so which affect your data, which will be the outlier. So you have to find out what is the reason. So this might be the reason because he was not in the 7th standard, so you have to remove that test from your data set in order to get the good symmetrical data. I hope you get this presentation, and this was actually about the central tendency and just theory. Okay, so and first we cover the theory portion, and then we have to talk about the practical terms, like how to measure these things from an SPSS. Okay, the practical terms will be then after this theory session. Okay, so I hope you will enjoy it and you will learn about the central tendency, and that's why uh, now I will take a leave from now and hope to see you in the next meeting. Thank you. Thank you for joining.